All right, so now we get these initial value problems we need to solve. In other words, we're going to get rid of the c, right? So for this one, you're going to just do everything you know so far about solving differential equations and how do you find those initial value problems and what's going to come in. You're going to have to do some substitution. Don't have to do parts for this. I didn't find parts when I did this, but you could. So let's see. We're going to separate the variables here. I'm going to get the dx's with the x's and the t's with the dt's. So I'm going to see, I guess what I'm going to do, what am I going to do here? So I'm going to rewrite the problem first off. X e to the negative t dx dt equals 1. So I guess I'm going to leave the t, let's see. I know this is x times dx over e to the t dt equals 1. All right, because we made that e to the negative t a positive by taking the reciprocals, kicking it downstairs. So now I can separate those variables really easily. 1 times e to the t dt is a nice easy thing to solve. And now we're going to integrate it, find the antiderivative. So 1/2 x squared equals e to the t plus c. And then they tell me that when t equals 0, x equals 1. So at this point, I certainly can just do this, can't I? I know this is going to be 1/2 times 1 squared, because x is 1, equals e to the 0 plus c. Well, e to the 0 is 1, and 1/2 times 1, so this becomes 1/2 equals 1 plus c, so c equals negative 1/2. So I should be able to, at this point, just write in negative 1/2 and get an answer. Negative, oh, everything's frozen. Oh, here it's back. Negative 1/2. Now, they might make you solve this for x, so in which case would multiply everything by 2. So x squared equals 2e to the t minus 1, and then I'm going to take the square root of it. Now, one thing that's kind of cool about this is, you know how I know that y was positive 1 or x was positive 1? That tells me I don't need to take the negative square root. I'm going to use the positive square root. Okay, if this had been negative 1, that would have to do something like that. And we might want to then solve it first. Okay, but so that either one of these answers is certainly acceptable, unless it's a multiple choice question. Okay, so now let's get rid of this work. Let's slide this over and do problem number 10. So I'm going to get rid of the x's. Let's see, I want to separate the variables, so I'm only seeing one y here. So if I multiply both sides by y and multiply both sides by dx, I think that gives me y dy equals 1 plus x over x dx. And now we got to pull out our algebra hat. I mean, how do we do that? The left-hand side is not the problem. The right-hand side, if I think of this as 1 over x plus x over x, that gives me 1 over x plus 1, which is a lot easier to integrate. So on this side, I'm going to take the antiderivative. So 1/2 y squared equals, so on this side, I'm going to get natural log of x plus 1 plus some constant. Okay, so let's see, when y equals, when x equals 1, y equals negative 4, I got to remember. So let's move some stuff around here so I can solve this. Let's see here. So this equals 1/2, what was it, 1/2 y squared. Okay, I think, you know how, see that y is negative 4? I think what I want to do is I want to isolate this for y. So I'm going to multiply both sides by 2. So So 2 times the natural log of x. Let me rewrite that didn't write well. Natural log, 2 times the natural log of x plus, I think they should be x, shouldn't it? Plus x plus c. So that tells me this should be 2x, yeah. Sorry. 2x plus 2c, which is c. And then I'm going to take the square root, and because I've got that 1, negative 4, I think I'm going to write this as the negative square root of 2 times the natural log of x plus 2x plus c. And then now I'm going to substitute in 1 and negative 4. So negative 4 equals negative square root of, let me see if I can erase that, 2 times the natural log of 1 plus 2 times 1 plus c. Move this down. So I'm going to solve this for c. Well, let's see. Negative 4 equals negative times the square root. Well, the natural log of 1 is 0, so 2 times 0 is 0. So we have 2 plus c left. I'm going to divide by a negative 1. I'm going to square both sides. Subtract 2. So I'm getting c equals 14. So at this point, I can just, because I can erase this, I'm just going to write plus 14 there. And that is what I think is the solution to that initial value problem is. Okay. So now I'm going to erase everything here. It better be recording. Let's see. Sorry, having to watch me erase everything. So let's see, now we've done 10, so now I'm going to do number 11. So I'm going to separate the variables. Guess I'm going to write it as dy over y squared plus 1. And that equals 1 times dx. And I'm thinking that this will be, well, let's see. This is looking suspiciously like an arctan function to me. Let me take a look here. I'm going to stop this and take a look. Okay, so, well, you know, doing the antiderivative of this is an arctan function. So it's the arctan of y equals x plus c. So then if I do some substitution in right now, see, I've got that point, 1, 0. If I do that right now, what does that get me? That gives me the arctan of 0 equals 1 plus c. Well, the arctan of 0 is 0, and that equals 1 plus c. So I'm thinking c equals negative 1. Isn't that interesting? That's what I got when I didn't do this with arctan. Interesting. So what's the solution here? What's going to be the antiderivative? What's going to be this? So I know this is negative 1. So I guess to solve this for y, I got to take the tangent of both sides, don't I? So tan of x minus 1 is what y is equal to. That's interesting. Okay, so then I think I've got one more problem to do. and then I'll be done with this and get back to the weekend. Okay, it looks messy. It's not too bad. So what I'm going to do is I'm going to try to get the x's and the dx on the other side. So what did I do here? I subtracted x, so that left me 2y times the square root of x squared plus 1 dy dx equals negative x. And then I divided by x squared, square root of x squared plus 1, and I multiplied by x, so that left me 2y dy equals negative x over the square root of x squared plus 1 times dx. Okay, now it's taming down a little bit. Left-hand side, no problem. Right-hand side's a little messy. This isn't an arc sine or arc cosine because I don't have 1 on top. And the other thing that I noticed, well, I knew that this derivative of x squared plus 1 is just going to be 2x. That looks like a u substitution to me. So I went u equals x squared plus 1, du equals 2x dx. Then we're going to get rid of the 1/2. Get rid of the 2 by writing it 1/2 du equals x dx. So that lets me rewrite this as, I'm going to pull the negative out, pull the 1/2 out. That's going to give me 1 over the square root of u du. Okay, so I guess let's keep going with this. So this is going to be u to the negative 1/2, which we're going to add 1, so that becomes u to the 1/2 divided by 1/2, which is the same thing as multiplying by 2. So I've got negative 1/2 times 2 square root of u, and the 2's cancel out. So I'm left with over here, what am I left with? Negative square root of x squared plus 1 plus some constant. And on the left-hand side, I'm left with, let's see, that becomes 2 divided by 2. That becomes y squared equals that mess. Here, let's scroll down here and put it all together. So y squared equals negative square root of x squared plus 1 plus some constant. And then they tell me that, let's see if we go back up and look at the problem, they tell me when x equals 0, y equals 1. So I've got this point 0, 1. So 1 squared equals negative square root of 0 squared plus 1 plus c. So 1 equals negative square root of 1. So 1 equals negative 1 plus c. c has to be equal to 2. Now, I guess we could think of this function this way. I could think of this as y squared equals 2 minus the square root of x squared plus 1. That way it's not looking like I'm taking the square root of a negative number. And then, so now I am going to take the square root, and I probably want the positive square root because that's positive 1. At least that's what my inclination is. So I think that's what the antiderivative is. And now, if you have done watching this, and I'll give you time on Thursday to do some book work, you're going to do the homework exercises on this handout. So good luck. Give a yell if you need help. Later.